Did you know that we lose around 10 million hectares of forest every single year? One of the most shocking deforestation facts in recent years is that the Amazon, the world's most biologically diverse ecosystem and important carbon sink, is found to emit a greater number of carbon dioxide than it is absorbing as a result of deforestation, wildfires, and climate change. If we take a step closer to these situations, you would agree with me that issues like deforestation do not gradually eat up a forest. Instead, its suddenly emergence, like what you see in this picture, could catch one off guard. This is a series of images of the Amazon forest cover from the year 2000 to 2019. They were taken from the exact same position and are in chronological order. You can see that at a particular point in time, the greenery of the image suddenly changes to barren spots. This is the point in time that deforestation began. Such unusual, or as we call it, anomalous behavior would occur within a short period of time. It is now impossible for a human observer to accurately realize that something is wrong in its early stages. Similar behavior can be seen in many other circumstances like natural disasters, improper urban development, and medical deformities and distortions. What if there is a system to detect these kinds of unusual behavior early on? A system to detect anomalies and provide possible prevention or other assistance required to mitigate the destruction caused by these incidents. Our undergraduate thesis is about detecting anomalies in image streams, which is identifying sudden changes in a collection of images that have been gathered over a certain period of time. These image streams are the data we input to our system, and it is important that the images are ordered relative to time. The objectives of implementing a novel system to detect anomalies are to first extract parts or patterns in the images that describe what we can see. Upon obtaining a set of features that define our images, we can detect anomalies through a novel framework that is proposed in our study. During our model building process, we have identified that finding a properly labeled image set that suits such situations is hard. Moreover, in such image series, the number of anomalous images available is comparatively low. Hence, almost all the accessible image sets are imbalanced, where there is a high number of normal images and only a few anomalous images. This is why our models are built based on typical behavior. In the case of deforestation, the typical behavior is when the forest is covered in greenery with no signs of deforestation, or any deviation from this typical behavior is identified as an anomaly. In our study, anomaly detection was done using two separate subsets of AI, machine learning and deep learning. The two models help us discern which technology is a better match for dealing with certain factors when detecting anomalies. For example, we observed that the machine learning model provided more accurate results for a small number of images, while deep learning was able to handle larger numbers of images. Let's say we do all of that, and now we have a great system that only takes in some time based images and figures out whether or not there is any unusual behavior. We will then offer this system to stakeholders such as a forest conservation department so that they can monitor the ongoings of a certain forest. But how are the users going to trust a system that only outputs a binary answer? We need to give the users more perspective on how the system derived the conclusion it came up with. And for that purpose, we employ a new field of AI named Explainable AI to help the users understand the system's output better. After testing our system on several datasets, we are confident that our novel framework could be used for the early detection and prevention of disastrous or unfortunate events. We hope it will be a step closer to saving our valuable forest covers, among many other use cases. I am Rashmi Perera, an undergraduate of the University of Moratuwa, Sri Lanka, and I presented to you our research on anomaly detection in image streams with explainable AI on behalf of my research team consisting of Nethmi Wijesinghe and Nethmee Sellahewa, supervised by Dr. Priyanga Talagala. Thank you.